All right, our third and final triangle similarity shortcut theorem is side-side-side similarity, or SSS. So this says if the ratios of all pairs of corresponding sides of two triangles are equal, then the triangles are similar. So this is saying if you know the lengths of all the sides on two triangles and you do the ratios of all the corresponding sides, you always get the same number, then the triangles are similar. So let's look at an example of that. So we know all the sides of the little triangle, we know all the sides of the big triangle. Let's find a ratio. So the side AB, that would correspond to the side DE. So AB over DE, that is 7 over 21, which is 1/3. Okay, so let's check our others. So BC over EF, that's 4 over 12, also 1/3. CA over FD, 5 over 15, also 1/3. So our ratios of corresponding sides are all equal. All right, so given that information, that AB over DE is equal to BC over EF is equal to CA over FD, we can conclude that triangle ABC is similar to triangle DEF. And what we get from that is then that their pairs of corresponding angles are also congruent, because that's the additional part of being similar that we didn't know already, that wasn't labeled on these triangles, that we can then conclude from knowing that they're similar. Okay, so let's look at an example of how to use this to solve a problem. So, given the side length shown below, prove that AE is parallel to BC and that AB is parallel to DE. Okay, so we have all the sides of this little triangle and we also have all the sides of this big triangle. So let's see if we can get some ratios of corresponding sides and see if they're equal to each other. So let's start with AB. That's 5. What's its corresponding length? AB corresponds to DE, which is 10, so that's 1/2. Okay, BC, that is 6, and what does that correspond to? BC corresponds to EA, which is 12, so also 1/2. And then, let's see, CA is 4, and that corresponds to AD, which is 8, so also 1/2. So we know that our ratios of corresponding lengths are all equal. So we have AB over DE equals BC over EA equals CA over AD. Therefore, we can conclude that our triangles are similar. So triangle ABC is similar to triangle DEA by side-side-side similarity. All right, from that we can conclude that all pairs of corresponding angles must be congruent. Okay, so let's find some pairs of corresponding angles. All right, let's look at ones that might help us with EA and BC. So those are two parallel lines. Here they're cut by a transversal, and I would know that this angle is congruent to that angle. So we know that angle EAC is congruent to angle BCA, because those are corresponding angles on similar triangles, right? That proves that EA is parallel to BC because alternate interior angles are congruent. Okay, so we've done one part. Now let's see if we can get the other part. So let's clear out that blue stuff. Now we want to get BA parallel to ED. Okay, so let's see. Here they're also cut by a transversal, and we would know that that angle is congruent to that angle. So we know that angle EDA is congruent to angle BAC because those are corresponding angles of similar triangles. And therefore we can conclude that BA is parallel to ED, again because alternate interior angles are congruent. All right, so that's a quick overview of side-side-side similarity and an example of how to use it to solve a problem.